today's task, your challenge will be to build and design an aerodynamic glider.
You'll have access to unlimited resources, but time is limited, so choose wisely and design carefully. The mathematics of projectile motion will be key in this challenge as you design and build gliders. Be careful though, you'll need to balance the weight and lift of your glider for the best aerodynamics, otherwise you won't win this challenge. So let's talk about building a glider. There's a bunch of things that you'll get to choose in this challenge and a set of other things that really you'll kind of be restricted on. So I'm going to kind of tell you those in hand, right? Firstly, when you build your glider, and it might look something like this, the first important thing is, where is the center of mass for your glider, right? In other words, if you were just carrying it, the center of mass, or what we call the barycenter, you could, actually, let's just see if I probably can't do it on this. You could balance your finger on it, no, let's find it, and it would stay exactly in place. A bit like how a basketballer might spin a ball, and they would have their finger in exactly the right spot, and it just spins around on that. To find the center of mass, or rather like where do you want the center of mass of your glider? You can actually find the center of mass of a straight object, like say the fuselage of the glider that you build, by doing something really simple. If you just take two fingers, do this, just move your fingers in. One of the cool things is, what's slowing down my fingers is friction. And the further away I am from the center of mass, the more friction is applied. So I'm not deliberately like thinking about where I'm moving my fingers. I'm just moving them independently of each other, and they eventually settle on the center of mass, right? So physics kind of does that by itself. I didn't know, like I didn't need to measure that. And even if there were actually weights inside this so that it wasn't evenly balanced, I might measure out and say, oh, I think it's there. The center of mass might be somewhere else. Like I could have put masses here, and that process of just going to the middle will find that center of mass. Where do you want your center of mass to be? You can put it anywhere, but have a think about what would happen if you had, you've got this made out of balsa wood, for example. You will have some other things that you'll need to carry on your glider, some bits of metal and that kind of thing, which will weigh down your aircraft. You tell me what would happen if the center of mass was near the front of the glider. It's just going to nosedive, isn't it, right? So you want to distribute your masses so that it's going to be somewhere actually near the center. More specifically, have a think about where it is in relation to the wings. Probably just a little bit behind the wings is the best place to go, but you'll actually be able to test that out, okay? So that's the first thing, center of mass. The second thing is, when you think about how to get lift on your glider, right? You've got your wings, which you're going to be making out of balsa wood, but if you just have them horizontally, as air transfers above and below, you're not going to get enough lift to actually fly much of a distance. So you want to have this angled at a certain amount, okay? Now be as precise as you can. I think what you'll find is if this was the actual fuselage, which I've grossly exaggerated, then you want an angle of about 5 degrees in here, which isn't much, so you really need to measure carefully, because even if you're off by 1 degree, right? In this case, 1 degree is 20%, so it can really make a big difference. Yep. You are going to make your fuselage out of a piece of balsa wood. This part's important, you'll need to measure it. You're limited to 50 centimeters. That's the longest that you can make it. But in terms of the wingspan, that's up to you. However, I think you'll work out eventually that there's a natural limit to how wide you can make this. If you make it really, really wide, think about this, right? There's going to be more drag on the front of this, so it's going to slow you down, and you'll need to balance that out yourselves, and you can make those decisions, okay? Now, I talked about choices that you can make. So this 5 degrees is one that I would encourage you to get to as close as possible, but then you have some genuine options depending on what your design looks like and then how you want to fire it. So most of you probably know, if we think about projectile motion, if you have a flat surface and you're firing an object off into the air, number one, what's the name of that shape?
Parabola.
That's actually a parabola, so you can get that by a quadratic equation. You will always get a parabola of some kind. If you fire at a lower angle, you might go like this, right? If you fire at a higher angle, something like this, you're going to have a choice of what angle of projection you fire at. It's going to be somewhere between 15 degrees, that's the lowest you can do, and 45, which I don't think I've really drawn on here. That'll be the highest that you can choose. You also can decide how far, or rather how much force you're going to apply when you actually launch your aircraft, when you launch your glider. Now, you're not just going to be throwing it, okay? That would be a bit imprecise. You're going to use an elastic launcher. So the more tension you put into that elastic, the harder it's going to go. Maybe you don't want it to go quite as hard because that's going to make your aircraft fly up and then come back and hit you. You have to be quite careful about that, okay? When you are doing your design, we're not just going to look at how it flies, we're actually going to look at your construction. You want to think about things like not just the wings, which are providing lift, but these things back here, these sort of fins, does anyone have any ideas? What purpose do they serve? Fantastic. So in order to have it actually fly in a straight line, things like these actually provide stability to your aircraft. So we want to look for things like that. We want to also look for things like symmetry. This has been designed and built and manufactured, so it's going to be symmetrical, but you're going to be creating your gliders by hand. So carefully designing, measuring out, and then actually creating the shapes of your materials, you need to be very cautious. I'm so excited to see what you build. Do be careful because these materials do get damaged easily, so you want to factor that into your design as well. Good luck, teams. Let's start building.
10, 9,
Let's do this one here.
8, 7,
We're done.
6,
Oh my God.
5, 4, 3, 2, 1.